Data type is a very fundamental concept to understand. Basically, every time you want to declare some name constants or a variable in order for you to manipulate in your program, you must declare first what type it is for that particular name constant or variable. We'll see example later, but let's see what the definition is. I would say for now, it may be quite challenging for you to really appreciate what data type really is, because now we only talk about simple values like an integer or character or boolean. Later on, once we introduce about objects after the reading week, I will try to revisit the notion about data type. For now, I would say just try to remember the definition. Okay, a data type denotes a set of related runtime values, which means we are trying to think about how the values can be categorized or can be grouped into different kinds. So what types do we have? We got integer type. So let me just, okay, so here, let me try to help you read the table over here. So in order to really store integer into a particular variable, you have to declare the variable to be of integer type. So now it can be byte, it can be short, it can be int, or it can be long. I would say as far as this course is concerned, I think int standing for int over here, standing for integer for 32 bits, it should be sufficient. But later on, there might be some occasions where you may want to see say long, which will give you much more space to store the integer. So just a little bit of information here. I'm not going to test you on this, just for your information. For example, for the bytes, so what will be the largest integer you can store in the bytes? Think about 8 bits. So every bit can store 2 possible values for the integer, right? So now you can think about 2 to the power of 8 will be 256. So if you look at the set of values over here, starting from minus 128, and then including 0, so up to now, we got 129, right? And then we got another 127 over here. So now, the largest number we can store is not 128. We had to say minus 1 because we have to accommodate the number 0. Anyway, so the point is 2 to the power of 8 for the 8 bits can store 256 different values over there, right? That's the main point. And then if you want to store larger range of integer values, you have to increase the size. It can be 2 to the power of 16, or 2 to the power of 32 over here, right? So you can see in the case of 2 to the power of 32 over here, it would be starting from minus 2 to the power of 31, right? And then 0, and then maximum will be 2 to the power of 31 minus 1. So you together multiply by 2, you get 2 to the power of 32, right? Just a little bit math over here. Don't be too bothered by that. I would say as far as the programming writing is concerned, you can always okay to simply use an int over here. So what about floating point number type with a fractional part? Again, similar. You can either use a 32 bits float to store, or you can use a 64 bits to store using double. I would say using either one over here might be okay, would be acceptable. But I would say using double is okay, right? That's that really give you the maximum storage for your numbers. Number 3, we got character type to store a single character. So that's a char, C-H-A-R. By the way, every word over here is so-called a keyword, meaning that you have to spell it right. You cannot say, for example, capitalize I and the NT. You got to say lowercase is I-N-T. You have to spell it right. Otherwise, it would be a syntax error. Okay, character type, and also we got string type. One thing to mention very quickly, but I will revisit this. Number 1, 2, and 3, so these are the so-called primitive type. However, the string type over here, I would say before we talk about objects after the reading week, it's okay to think about string like a simple types that we are dealing with. However, string is not really a primitive type. String is so-called a reference type, but we only need to worry about this distinction maybe once we talk about objects. I'll leave that until later. And whenever you declare, notice that you can see even the spelling for the string should be capitalized S over here. So string will be the set of all possible character sequences, right? All right, so now how can you use a data type? So now you want to declare a variable v to be of certain type t. So the t over here can be any of the above. It can be byte, short, int, long, float, double, chart, and string, any one of them. And then whenever you declare a variable or some name constant to be of that type, you can only reassign value to that particular variable. Let me show you. Okay. We'll see more concrete details in the later video, but let me just clarify the syntax together with you. Okay, over here. You can think about these are the types that we just talked about. You can think about here integer, double, boolean, char, and also string over here. Every one of these is so-called data type. Okay, and then over here, let me use blue. So the I, D, B, C, and S over here. So these are basically the names of the variables. Okay, I'll talk about variables versus name constant in the next video, but let me just annotate that. So these are the names of variables. So variable names. Okay, and then, so let's see, so what does it really mean when you want to declare I to be of type integer? So now, let's say this one specifically, let me just try to explain that over here. As soon as you declare this, what's the consequence? So the consequence of declaring, okay, let me write it more properly, of declaring variable with name I of type int. What's the consequence over here? So the consequence is at runtime, only integer values can be, actually here I say integer to be more precise. It should be the integer within that 2 to the 32 the 32 bits range, right? So only integer values can be stored in I, right? For example, if you try to say I should be assigned to, for example, 1022 over here, a string literal, this will be considered as type incorrect, right? I will speak more about type incorrectness in the later video. I just want to give you one example right away. Okay, so depending on what data types you actually declare the variables to be, you can see D is of type double, and B is of type boolean, and C is of type character, and S is of type string. So as soon as you declare these variables to be its corresponding data type, there's only exactly one data type you can declare for each variable, and you cannot change it. Once declared, you cannot change the type of a variable, right? It's really important to note, right? So here I simply put question mark, simply means what kind of value can you store into each variable, right? That's something I will elaborate in the next video. Actually, I changed my mind. Let's not wait. Let's now introduce name constant versus variables. Let's do that now. Okay, so a name constant or a variable, either one, is actually an identifier that refers to a placeholder. When I say identifier, I mean a name which you can, like a symbol, like a name you can actually manipulate in your program. You'll find that very useful. We'll see many examples throughout the course. It's more like a placeholder. Think about it as a place, like a box, for you to store a certain value depending on what the type is for the box. It must be declared with its type. Remember what we said before, whenever you declare something, you must have the data type over here to declare. Integer, double, boolean, character, or string. So this part here is really mandatory, okay, over here. Some programming languages do not require you to really declare types for variable, but that's not the case for Java. They got something called strong typing, which means whenever you introduce a new name to your program, you must declare the types for that particular name constant or variables. Please keep that in mind. All right, must be declared of the type, and the type is going to constrain about the values you can store into that particular variable at the runtime. We'll see. Okay, and then let's take a look at this example here. So now, just by looking at the declaration, can you tell which one is a name constant and which one is a variable? You can see the only difference over here is the final keyword over here, right? So let me make it more explicit for you over here. You can think about what we're doing here is this. So we got final. This is a keyword in Java, and also double, and also let's say pi. Okay, and the equal sign over here means it's initialized or assigned to some value. Let's say 3.14. Okay, and let's see what the other one is. The other one is radius. Okay, that one is a variable. And that one here is double, and then radius is, for example, let's say you can give some initial value, or you can choose not to initialize it. Let's say 23.4, right? It's a double. So now, how can we tell which one is a name constant and which one is a variable? Basically, you want to pay attention to the keyword over here, final. Final means the value that you initialize that into is the final value. You cannot change it, right? So that simply means over here, this will be the initialization. Initialization of the name constants, constant with the name. Okay, so pi. So this is the name of the constant, 3.14. And think about this part over here is the type of the name constant. The type of name constant. Okay, and the final over here simply means once initialized, cannot be reassigned. So this is exactly the difference between a name constant and versus a variable, right? So I'm gonna highlight this over here. Just cannot be reassigned. Okay, so that's so the final keyword is the one you want to look for. So what about variable over here, just below, over here? So let me use a green over here. So you can think about this is the name of variable. Okay, and this part over here is the initialization of the variable. And let me note that this part over here is optional. And if you look at the example I put on the slides, you can see the radius over here. I simply didn't put any initialization. That's okay. So for the variable, you don't need to give any initialization value, in which case it's just going to give some default value. In the case of double, it's just going to be 0.0. Okay. On the other hand, so now when we talk about the initialization for the name constant, so this one is mandatory. So you might be wondering, what if I don't have the initialization for the name constant? You're going to run into some error, more like a type error. I'll show to you over here. Okay, so you can also find this particular class on the Java project archive that I just showed to you previously. Okay, so now let's see what's happening over here. So we declare some name constant. You can see the final keyword over here of type double, and the name is simply just pi. Here you can see that we are giving an initial value to this name constant called value 3.14. So this is legal. So what I would like you to try is, if you simply just get rid of this particular initialization part in your code, and let's see what happened. I predict the Eclipse compiler is actually going to tell you that there's an error over here because you declare some name constant, but you didn't give any initialization. I would like you to verify this on your own. Okay, do that. But if we got initialization, that should be okay. So there are two requirements for the name constant. Let me summarize. Number one, you must initialize the name constant. Number two, you cannot reassign the values for the name constant. That's why I want to show you this screenshots over here. Okay? And this example is also included in your projects that's imported. So let's see this. We want to visualize what's really happening over here, right? So remember I said either the name constant or the variable, they're like a placeholder. So you can think about here, the name constant I have is like a box over here. And then its type is actually double, which means I can only store double value at the runtime in this box. And then pi over here is the name of the name of the constant over here, and the initial value I put is simply 3.14. And now if I say over here p is assigned to another value, I intend to really assign that to be 6.28. That's what I intended to do. However, the compiler wouldn't allow me to do so, right? So now this simply not going to be not allowed. This attempt not allowed. Okay, so this is going to be the error. You can check it in your Eclipse. So this is reassignments of the name constant here simply would not be allowed, because once you initialize that to be some value, for example 3.14, it must remain that value throughout the lifetime for this particular name constant for your program, right? Only if you declare the variable of the name to be a variable could you actually reassign that variable multiple times. We'll see that. All right, so that's about the difference between variable versus name constant. Okay, let me go back here, and the slide simply just summarize what I just said. Okay, so you can only store value that is compatible with its declared type. So what I meant was over here you can see I declare, for example, pi to be of type double and radius to be of type double. So now what initial value can I put? I can only put double value over here. So what if I try to put, for example, here, hypothetically, rather than 3.14, I try to put maybe 23.4, a string literal. Maybe I try to put a character over here, right? So these will all be incompatible, right? So you can think about these are incompatible. Meaning that you're going to get a type errors. And remember, in the compiler time, there's one kind of the errors you can get, either syntax or type errors. So this is the type errors that you might get. If you simply try to store values that's incompatible with the variables or name constants declared type, be very careful. Okay, let's come back here. However, a name constant and a variable are different in that, right? So this is where we talk about the difference. A name constant must be initialized, number one, and also number two, it cannot be changed, cannot be reassigned for its store value. I just illustrated to you. And also for the variable, number one, it may not be initialized. Okay, you can choose not to initialize it, in which case you will get some default value. And then you may change its store value as many times as you like. Let's see one example right away. Okay. Let's see this example here. You can see we don't see the final keyword over here. It's simply data type, data type, data type. So we got I and J. We got two variables over here. Okay. Let's see. I will talk about target versus source. Maybe I should talk about it right now. Okay. You can think about this. Whenever you got an equal sign, a single equal sign, so that means you're doing an assignments, right? You will see also in the slides they talk about the definition for assignments. So here you can think about this equal sign over here is an assignments. You want to assign so-called the right-hand side. Okay, whatever we call expression over here, the simplest form will just be a number, but it could be some complicated expression, which I will talk about in the next video, which could be just another variable, meaning that you're going to store whatever that's stored in that particular variable and assign that into the left-hand side. Okay, we will see. So we call this the right-hand side, or the source of assignments. Okay, and then to the left of the equal sign, over here we got I over here. Okay, so here you can some people say it's the left-hand side, or it's the targets of the assignments. Okay, the right-hand side you can see it can either be a value over here, or it can be another variable. So that's why we want to trace the program. Right? We want to trace it to see exactly what's going to happen. Okay, let's see. First of all, we are declaring integer variable, two integer variables, I and j. Let's visualize it. What's going to happen is we're going to have I and j. I over here is a box that stores integer only at the runtime. And also we got j, another box that also stores integer values only at the runtime. Initially, so you can see I is initialized to be 24. And j is initialized to be 32. Okay, 24 and 32, right? Now, number 3 over here will be very important to understand. We're trying to do another assignments, so we're going to basically whatever that is stored on the right hand side or the source, copy its value over and store that into the target. Copy and store into. Okay, what's going to happen is you can see j over here store the value 32. Copy that over to the target, which is I, and then replace it, right? You can only the box can store only one value at a time. So we're just going to replace it by this value that's going to be copied over, which is 32. So now you got two copies of 32. You got 32 here, you got 32 over here, right? So after this reassignment, you can see I and j both store 32. Okay. Finally, let's see another one. So here we got another variable declaration. We got k of type also integer to be initialized to be the value of I. So we got k over here, and then k is going to store the value that's in I, right? I is got 32. So we're going to copy this over to here. So we also got 32. All right, it's a very simple tracing over here. Hopefully you're okay with that, right? So my main point is you can reassign. You can see, let me highlight it over here. You can think about this particular equal sign over here. We are basically reassigning the value of I. Reassign the value of I. You can see I value used to be 24, but it can be changed to 32. For variables, you can reassign its value for as many times as you like. Okay, but for name constant, you cannot do it, right? So now we talk about variables. All right, so we talk about type. We talk about assignment targets versus assignment source. Target is basically the left-hand side, and target, the source, is actually the right-hand side. Okay, let's now go back to the slides. Okay, for assignments, for this particular slide, let me see if there's anything new. This is basically exactly what I just illustrated. For every assignments, you basically are going to replace the old value by the new value. Okay, for example, here, I replace the old value, which is 24, by the new value, which is 32, right? And then an assignment is done using the assignment operator. It's a single equal. Okay, let me now clarify this, hopefully, just once, but I'm pretty sure I might need to clarify for you multiple times, which is okay. In Java, one of the top confusion by beginners is like this. So now, if you got equal sign versus double equal, they mean things completely different. So when you say equal sign over here, this means assignments, meaning that you're going to change the values of maybe the name constant initially, or to change the values of the variables, right? And then for equal, that means equal. It's more like a value comparison. Okay, and then more further to the points over here, equal, we say that it's a relational operator. Meaning that it's going to evaluate to either true or false. And I will speak a little bit more about this now next week when I talk about selection. On the other hand, so here, the single equal over here, this is the assignment operator. Assignments operator. Alright, just please make sure you don't get confused about between these two operators. You gotta use the right operator at the right time. Okay, and then assignment operator has two operands. You got the left and also you got the right, right? So, and the value for the right hand side, the source must be compatible with the target, right? I already illustrated for you. And valid assignments, you can see name1 was declared to be of type string. Only string values can be assigned to it. Either string literal or maybe just another string variable, which means we're going to copy the string value in that variable over to the target, right? Either way. And then what about invalid? You can see we got name1 over here also declared to be a string. So now what you want to ask yourself would be, is this a string value? It turns out it is not, because you can see this one here, 1 plus 2 times 23 modulo 5, which will find, oh, by the way, this will find the remainder, right? I just talked about it. So you can think about the right hand side is simply just a number. You cannot store a number into a box that is supposed to store strings. Okay, it's simply not type correct. It's not compatible.